All right, guys, I think everybody is in here that's going to be in here, hopefully, or they'll miss out. But I'll go ahead and get started. So my name is Ryan. I'm going to be talking about weaponizing Splunk. A little bit about myself. I'm the Director of Security Engineering at TBG Security. We're a consulting firm out of Boston, and we specialize in offensive security. Some certs up there. Hopefully it means I know a little bit about what I'm talking about. I don't know. So this talk came from last year. My team and I were on an engagement. We had gotten internal access to the organization, and during recon and enumeration, we found a Splunk server. Really cool. We navigated to it, and it was very nice to us, and it just logged us right in, and logged us right in as an admin. So I was like, that's awesome. But what can I do with this? So we built a custom application. We installed that. It allowed us to get root access on the machine that we were on. And then we thought, hey, how can I expand this out? How can I get more access into the internal network of the organization? So we built more custom applications, and then we utilized the functionality of Splunk to deploy these out to every system in the organization. And within about, a few minutes, we had, domain admin, and we had access to every box in the organization. So that's kind of where this whole thing came from, and I'm just going to go through the steps of what we did to actually build those and exploit the organization. So we're going to start out, I'm going to talk a little bit about Splunk and some of the basic functionality that Splunk has so you guys know exactly what I'm doing during the talk. Some of the misconfigurations that we see, just the basic stuff. And then I'll actually talk about what I mean when I talk about weaponizing Splunk. There's basically 3 attack surfaces. We're going to be attacking the server, attacking the organization, that'll be the lateral movement, and then attacking the data. That last part is more moving away from actually using a customer Splunk instance to utilizing your own Splunk instance. During a pen test, we generate tons and tons and tons of data, and it takes time to review all that data and generate the reports. Everybody hates that part. I know I hate that part. It's the worst part of it. So if you utilize Splunk to bring in all that data, we can actually speed up that process, and it actually speeds up your attack as well. So I'll talk about that. And then finally, I'm going to wrap it all up with mitigating actions. A lot of this stuff Splunk's already put together for you. People just don't read the documentation. So we'll kind of talk about that just real quick at the end, because if I tell you how to attack it, I need to at least give you some options on how to fix it. So, what is Splunk? It's a log aggregation and correlation tool. It's very powerful, has the expandability through what they call applications, and all these applications they can be written in a lot of different scripting languages. Python, Perl, Bash, PowerShell, things like that. The nice thing about the applications is it gives me command execution on that host. I can run anything I hand it. And there's really nothing to stop you as long as you have the right privileges on the application. So some functions within Splunk that we're going to talk about later on in the presentation. One aspect of Splunk, since it needs to gather all this data, it needs to have a way to get the data, right? So a lot of applications offer syslog, so that it'll send in the logs, your network appliances and stuff all offer that. But some of the applications, such as, just Windows in general, doesn't offer syslog. So Splunk gives you a universal forwarder. That'll install the operating system, collects all these logs that we're talking about that are already on the hosts, and then also, again, is expandable by applications and gives you command execution. It's really nice. All these universal forwarders are controlled by what's called a deployment server. So the deployment server basically allows you to collect all these universal forwarders. They allow you to split them up into, different categories. Basically different categories, but based on host names or operating systems. And this just helps you manage the deployment so that, if I'm looking at a Windows application, I'm only deploying Windows applications out to Windows hosts and not deploying out to Linux boxes and things like that. So here's just what the deployment server looks like. I get my clients. I can break them up into classes, which is the categories. And then I decide the applications that go to classes, and the classes decide what applications go to which hosts. So that's basically Splunk in a nutshell. Oh, and if you guys have any questions or if I'm going too quickly, raise a hand, ask some questions. I don't mind the dialogue while I'm talking. So the misconfigurations that everyone sees. The older versions of Splunk, the one that I was talking about earlier, I think it was 4.5. These have been fixed in the new one, but that automatically logged you in if you didn't have credentials set up. The default passwords, admin and change me, Every version prior to 6.5, which is the current release, didn't require you to set that password. It automatically had it configured for you. So if you run into that, SSL is another one. It's a check in the box. Nobody ever checks the box though unless you call them on it. So if there's no SSL configured, you can do man-in-the-middle attacks as long as you're internal to the network already. And then always, Splunk, I find this every single organization I go into. Maybe the Splunk application isn't running as root, but all those universal forwarders, they will be. And that's actually the key to the entire attack. So Splunk's always going to be running as a privileged user, unless you have a, reputable organization install it for you. Maybe like us, I don't know. So weaponizing Splunk. So the three attack surfaces that I talked about earlier, attacking the server, attacking the organization, attacking the data. Attacking the server is, I have access to that server. I have those admin credentials. Somehow I got them either through credential reuse or one of those misconfigurations that I just talked about. The first thing you want to do is you want to know your environment. So look at the logs that are already in Splunk. Are there Windows logs? Can I look at those Windows logs? Things like that. Splunk allows you to read in files from the operating system, the local host that you're on. So let's start pulling in files. Etsy shadow, Etsy password, groups, hosts, anything really. If it's a Windows box, look at some of those files. So start looking at the local files on the machine. And then we'll get into the malicious application. Attacking the organization. So that's we're going to be abusing the trust with the universal forwarders that are already out there. Let's send out applications that execute code on all those machines. Let's configure those applications to run every 5 seconds so that in case somebody catches me, I now have my shell back immediately. And then attacking the data, we'll be bringing in all our pen test data. I'm going very quickly, but it's cool. So reviewing the logs. As I said, let's look at the logs that are already in Splunk. Splunk is huge, and everybody's gathering everything because they need to know all this information about their environment. So you're going to find web application logs, Windows logs, Linux logs, everything, custom applications. So now I can go in Splunk and I can look up and say, hey, here's all my database servers. Here's a list of all my domain controllers. Here's a valid list of users that log in just today, actually. I can look at login logs and say, hey, this organization runs from 8 a.m. to 2 p.m. or whatever it is. They have a rotating shift. They're always in. Here's users that work different shifts. All this information can be pulled out of Splunk, and we can review that and immediately have all this knowledge in our hands being an attacker. If it is custom web app logs, we can go in there and look and say, these users have higher level privileges than other users. Here's things that I go and look for, just some key terms to throw out, username, password, things like that. Those are really going to get you the quick wins. And here's some files that I usually go for. The SSH keys, that's really fun. If I can't get command execution, maybe it's running as a lower level privilege, but then I can grab these SSH keys. And when I'm looking at these things, I'm always one to build up attack profiles and kind of get to know my environment. How do they structure the host names? How can I look at the host names and kind of determine what these boxes, what the function is in the environment, and build out, kind of an attack path of way I want to execute. So here's a quick demo. The nice thing about this, right, is oh crap. Of course. Bad resolution, we can't read. I even shot these at lower quality too. Alright, well, let's give up on that. Anyway, so you're going to add data, you're going to upload a log file from the local file system. And you're going to keep hitting next up here in the top right. And as long as you don't go all the way to the end, none of that information is logged. So if I pull in Etsy shadow, I can review the data, look at all those password hashes, grab those, throw them into my password cracker. But Splunk never knows Splunk knows I was there, but no one else knows I was there. None of the administrative users. So then I can just go back, pick a new log file, hit next, review that, collect the information I need, and keep going back and forth over and over again. And as I said, nothing is ever logged there. I hope my other videos show up because that's going to suck. All right, attacking the server, malicious applications. So I built an app. It's called Splunk Shells. Basically, when you install it, it's a Python reverse shell. Splunk is packaged. The main Splunk application is packaged with their own Python interpreter. It's 2.7. Sorry. So I built basically just a common Python interpreter shell, just a basic payload to demo the activity. So that we can show off. See, this video looks better. Okay. So let's start up a handler first inside Metasploit. Hopefully people are familiar with Metasploit a little bit, know what I'm doing here. So as I said, the shell that's going to be coming back is a Python interpreter shell. So we have to use proper payload. You can do reverse, you can do bind shells. It does support both of them. It does support basic command shells as well if you needed that. All right, so we have a handler set up. Now we need to go back to Splunk. We're going to use those credentials that we have, and we'll install an application. Come on. So the fun part here is we could substitute any code here that you wanted. Obviously I'm using a Python interpreter shell, but this could be anything. If you have something custom on your team that you guys use, if there's, some other function you wanted to run, all you gotta do is swap out my Python code for yours and install this and run it. The one setting that you have to change for 6.5 is that I haven't figured out a configuration file. There may be one. I just haven't figured out which one it is. But now, basically what this has installed is a command that we can run from the search and reporting app. So we'll run the app, we'll say, I want a reverse shell, I want an interpreter reverse shell, and here's who you need to talk to. So if you don't, this actually forks off the process. If you don't fork that off, that will hang and keep using the Splunk process to run and execute your shell. So the entire time that you're running in your shell, it would sit there. So you do need to fork off the process. The ones that I have built in do. So if you do swap them out, that would be one thing to keep in mind. And it also prevents the admin, if you restart Splunk, my shell's still there. It's still calling home. So there's that. Any questions there on that one? Yeah, all the videos will be on GitHub. Actually, the entire presentation is. The link's at the end of this as well. So, awesome. It's cool. Everybody wants to install it. It's on GitHub right here at this link. And as I said, there's another link at the end of this presentation as well. And I did have it in Splunk Base. The Splunk Base App Store. So I submitted it. It was cool. Everybody thought it was awesome. And then about 57 minutes later, they figured out what the hell was going on. And they told me I was crazy. I don't know who got in trouble for it, but somebody got in trouble. And so that got pulled. If it was in the Splunk base, it would have made it a lot easier. If you were a pen tester inside an environment, you can log in, literally say browse apps, type in Splunk shells and install it, never having to upload any code to them. So it would have been funny, but yeah, they caught on.
You're like the third person they busted.
Oh, I'm sure they have. I was gonna go down the route of trying to hide it and obfuscate the code, and I was like, no, it's waste my time. Let's just put it up on GitHub. People can download it. It'd be funny that way. So extracting data. So all these apps that we install, I guess not really mine because there's no configuration for it, but all the other apps that you install all need credentials to talk to something. Nextpose has an app. You need to give it credentials to talk to your Nextpose console. Windows usually needs a domain user. Usually it should only have read access. A lot of times it has more. But all these things need configurations. So you need to input a username and a password. So Splunk takes all those in through your app. It's all stored in a file on the file system. And luckily, Splunk does do it correctly, and they do salt and encrypt all these credentials. This is what it would look like for a Windows app. You install, or you set up your configuration with your username and password and everything. And if we looked at the actual file in the file system, this is what you would see. So you can't actually read anything. Awesome on Splunk's part. Bad on Splunk's part, because about 14 lines of Python code and utilizing the API, I now get clear text passwords here in the middle. So the API needs to be able to speak to all these applications. So if I give it a Windows username and password, it needs to be able to reach out to that domain controller or that other Windows system in the network and give it those credentials. So the API has to be able to unencrypt those passwords. Well, it'll also give it up to anybody else that asks for them as well. So as I said, with about 14 lines of Python, it'll loop through every application that you have and decrypt all those credentials and present them to you. That one's fun. So.
Can I make a clarification on that?
Yeah.
So that is and isn't true. So the encrypted password storage endpoint in Splunk prior to 6.5 required a privilege called admin all objects, which meant you were Splunk got.
Yep.
Because you had to have it. Now the developers, unfortunately, they have to deliver. They delivered a new capability called list storage password. It is still an all or nothing thing, but you do not have to give that right to everyone.
But if I'm an administrator, I have it. Or can give it to myself.
That's assuming you get.
Yes, correct. Yes. So there is a setting there. So but if you have administrator credentials, and this is assuming that you have in some way have administrator level access, you could either, if you didn't already have it on that user that you had, you could give it to yourself because you're an admin, or, if you already did have it. So yeah, you are correct. But that is new for I think it's 6.53 or 6.50?
List storage password is 6.5.
Okay. So attacking the organization, this is where we're going to talk about those universal forwarders and that deployment server that we talked about at the beginning. So along with the application that we talked about just a second ago, there's two what we call technology add-ons. It's just a Splunk way of talking about a different app. I built a Windows one and a Linux one. And again, these are all basic interpreter shells. You could swap out this code with anything that you wanted. So the Windows one is just a bat file, runs a PowerShell command for a reverse interpreter shell. The Linux one's all Python. It's honestly the same code that I used in the other application, just ported over to a technology add-on. And here's a demo of that real quick. So I use the Unicorn application to generate the PowerShell code. And as I said, a lot of times these universal forwarders are installed and running as root or system. So as soon as this code runs, it gives me a reverse shell. I also have those same level access. Any other questions while this is going through?
So from the start of all of this, the assumption is you had an account.
I have an account of some sort. There's either misconfiguration with a default password, there's password reuse in the environment. Yeah, the assumption is that you do have some sort of access into the server. There's really no vulnerabilities. I'm just a creative way of using the app. Pretty much. Swap out our PowerShell payload here with our new stuff. And again, all this, if you had some custom code that you guys use for your red team or your pen testing, that can all be swapped in here as well. This is just for demo purposes. I felt like Metasploit was easy. That looks like crap on there. At least over here we can read some of it. I had high-res videos, then you couldn't read it on the low-res projectors, so I swapped them. Now you can't see that. Anyways. So let's go forward a little bit. So we'll start up our handler. We'll go into the deployment server here, and we'll just, oh man, that looks horrible. One bad to the next. Anyway, so these deploy out. So the nice part with these technology add-ons is, again, we can set the restart time of the application. So if you needed it to run every 5 seconds, or if you wanted to run every 6 hours, whatever you really wanted, you could do that. So then whatever your time is, it'll kick that shell off again and again and again. Yeah, we'll just go with that because that sucks. Anyways, any questions there? That was kind of that section. Yes. So I started out with just putting PowerShell code, basically as a reverse interpreter shell with PowerShell. So I put that in there, and that runs basically every 5 seconds or 10 seconds, whatever you put. I'm sorry? Yeah. So the last section here, attacking the data. I'm super ahead. So as I said, we generate a ton of data with pen testing, Nmap scans, we're running NICO. Every tool that you have is going to generate some sort of data, responder, everything. All that stuff, unless you put it in Splunk, it all sits in text files normally for me, and I have to go through windows and windows and go through these crazy hierarchy of folders, and that's how it's all organized, and that's how I go back to read it and generate reports, and it takes me days, and it sucks. So, if we had it all in Splunk, for instance, this is the Wi-Fi Pineapple. This is just, hold on. Let me grab. Guess I should drag it over here, shouldn't I? There we go. Slightly better. Okay, so we have an app for the Wi-Fi Pineapple. In real time, all these logs are coming in from your Wi-Fi Pineapple. You can look at one single dashboard, and you get SSIDs. I get the clients that I've already got attacked or attached to my Pineapple. Down here at the top, you get 2 timelines for the different probe requests and the different SSIDs that we're seeing. And it kind of speeds up that attack. So now I know who's on my network, who I have already, and what SSIDs I'm seeing. In the future, I'd like to add some more context menus that I could drop down and say, hey, run this attack on this guy, and it'll run those scripts on the different on the Pineapple, so that it would start capturing everybody else. That hasn't been built yet. Right now, we just got dashboards, but we're getting closer. And the other app that we have set up, and I'm just going to do this outside of PowerPoint for now, would be Responder. So Responder is the man-in-the-middle tool. Kind of. It's good enough, I guess. Responder is the man-in-the-middle tool for pen testing. You'll run it. It'll do man-in-the-middle on SMB, HTTP, FTP, all the different protocols that are going across the network. It'll say, hey, whoever you're trying to authenticate with, I'm that guy, send me your hash. And so you collect all the hashes. And again, in real time, if we're sending all those logs into Splunk, if you're running Splunk on your pen test box, it would make things a lot faster. So up top, right away, I can, in real time, see how many credentials I've already captured, what type they are, what protocol they are, the usernames that I'm looking at. And then down at the bottom here, I cut off, and some of this stuff is blurred because it was actually live engagement I was on. Down at the bottom, I have the hashes that you could easily just export and kick over to Hashcat or John or whatever tool that you're using. And again, I would like to build out some context menus in the future to say, hey, run this in Hashcat, and it automatically pushes that out for you. Let's see here. It's going to start where I want it to. So we'll end it with mitigating actions, and I'm way ahead, but it's cool. Obviously, just update your software. I mean, as I said at the beginning, the engagement that started this, it was running a 4.5 installation that automatically logged me in as admin. Had they been running a 6.5 or a 6.0 installation, at least it wouldn't auto-log me in, but maybe they still had default credentials. So update your passwords, enable SSL. It's one check in the box. And then there is a secure deployment guide. There's a ton of stuff in here. It's about 15 to 20 pages long. There's a ton of stuff in here that you can do. do domain authentication, add in more complex layers besides just basic application stuff. But yeah, that's it. As I said, sorry about the videos. Never know what I'm going to run into here with the presentation. Any questions there? Oh, and there's the contact info. Bring that back up, sorry.
Are there any best practices on, obviously Splunk is a lot more usage than, I know they have the security fees, but, as far as like operations, watching operations of how servers are running and stuff like that, but there's other uses of importing different types of data. Are there any best practices on what you should and shouldn't import into it when you're giving access to people outside of IT?
Well, so you would want to, I guess, split your data up. So, I mean, for instance, if I had somebody in accounting that needed to look at something, only accounting data, you obviously wouldn't allow them access to look at all your IT data as well. So you can segregate out the data like that and assign users access to different, they call them indexes. So that would be different data sets. That's one thing, but there's a bunch of other stuff. Don't import your passwords, don't import things like that. Yes?
I saw you had given them kind of the overview of what you saw with Responder, what you saw with Wi-Fi Minus, and you give that to your customers, right?
So this would be more of something that I would be running in real time for myself to kind of keep an updated stat. If there is a cool chart in there, yeah, I would translate that into a report, but most of that is just for me to know right away, hey, I've got 20 NTLM v1 hashes or, whatever.
And do you usually only use that if they have Splunk on their network, or you're just using it?
That would be my own Splunk implementation. I usually pop that on either the Kali box or whatever box that I happen to be using. Yes?
To the gentleman's question about ways to segregate your data, even if you do need to import things which may have confidential information, you can actually configure Splunk to anonymize that automatically. There's a lot of different.
Yeah, so if you wanted to go in, if you had to pull in, for instance, like credit card information, there are ways using the configuration files to actually say, hey, just put X's for the credit card information, or, whatever regex pattern really that you wanted for data that you didn't want the entire piece. Maybe I only want 20 characters that line instead of all 50. You can do a regex and kind of pull out stuff or do whatever, yeah. Anything else? Yes?
So when you were doing the actual, not exploit, when you were like popping the interpreter shell and running commands, is that logged by Splunk? Is that something you have to clean up afterwards, or are you like free to do that?
Technically, it would be logged in Splunk. It'd be in the internal logs. That's normally not something I've noticed in engagements that people have like reports or alerts set up for. But yeah, it is something you would want to go back and clean up.
To that answer, I busted the red team last week by using a road deployment server that was not set up.
Yeah. So honeypots.
You watch the Splunk internal logs for like application downloads from deployment servers that are not your deployment server. Maybe you'll catch them like that. Same thing, about so you just use those internal logs.
Yeah, there's a lot of information in them. I don't see a lot of reports. Obviously, a lot more people have.
There's also internal auto logs, so
yeah.
if someone manually changed the file, that will be reported. Obviously, depending on how you have Splunk configured, you may not see, like out of the box configuration, you would not see the user that made that change, but you can install tools alongside of Splunk that will log that.
Yep.
So it just depends on how security conscious your organization actually is, which is kind of
yep.
like this conversation.
And 6.5 supports multi-factor with duo.
It does.
Which would have completely ruined your day.
It would have. I don't think I have any customers that run it yet. 6.5, yes, but not multi-factor. Yeah, I would still need that second factor authentication if we're going that route. Yeah.
So, what other additional data sources could
having something like Splunk that allows you to quickly search the data, allow you to exploit from a red team perspective. Like on the blue side, where I can go, hey, now I've got Splunk, I can pull in a whole bunch of data very quickly, find the gems in it. What's the equivalent to that on the red team side?
I mean, technically there isn't one. I've been kind of slowly building stuff out. The Pineapple and the Responder one dashboard that we have. Been working on an Nmap one that'll kind of show me really quickly things that are open.
So what other data sources in addition to the Pineapple and Nmap could you foresee using just to analyze or to dig into for red team?
I mean, there's tons.
What I would add to that is, Splunk has what they call the HTTP event collector. Makes it very easy to submit JSON payloads. So just modify your tools to submit, what's going on with your tools and what actions are being successful, things like that, via that JSON payload submitter to your Splunk instance for your pen testing, and you'll get really good data. Well,
Yeah.
But most of these things hide in the anyways.
Yeah. And any of your custom tools, a lot of this, if you start migrating in this route, you're going to have to either do a lot of configuration and regex matching to really get the true output on stuff, or if you have custom stuff that just output to JSON or CSV or XML or something standardized. Anything else? Cool. All right. Thanks, guys.